All right, so there's just a few of us today. There's only five of us. So as long as everyone participates at least once, then then after that, free game. It is science, so I do expect everyone to participate. I think three out of the five of you really enjoy science, so that gets me excited. So let's go ahead and start. Okay. We are on IXL. As a just a heads up, I guess, if you are reading, it says my trial ends in 7 days. I do get to use IXL. We get to use IXL for like a free trial, and then it'll try and get Mr. Hughes to pay for it. Um, Unfortunately, IXL is very expensive, so in 7 days we will be using a different website. So while it's free, if you ever want to explore this website, you're more than welcome to. They have things like math, language arts, social studies, Spanish. It's very fun. It is free for the next 7 days. If any of you like really love just science or you just want to like just learn more, that's totally fine. Um, I just want to let you know that, Miss Dela Cruz just texted. Uh-oh, what is that going to be about? You don't see Daniel. Never have I ever. And is this honest and naive? Yes. Okay, we are looking now. The link keeps saying connecting with a black screen. Honest Ayub, are you here? I think they're trying to get in. Um, it says that they're connecting. Sorry, I'm just taking a picture of that real quick. Honest Ayub, are you guys in? Maybe, maybe not. Hey, yeah, so much texting today. I do not want to deal with all that. Honest Ayub, if you're here, I can't hear you or see you, which is fine. Feel free to use the chat box today, but it says you're here, so I'm assuming you're here. Um, I don't know if you can. It works on the phone. We just tried it on my phone. Okay, cool. Well, then that means you're here. So hello. Um, I'm glad you're here. Um, yeah, I can't hear or see you. I hope you can hear and see me. And again, please feel free to use the chat box, you two. But yeah, we're about to get started. Um, yeah, we are moving down to, where are we moving? Chemical products, soap making. What are we doing? Reacted to products. I'm just trying to remember, guys, what we're supposed to be doing next because we're not supposed to be doing this one. I know that much at least. And oh, it is this one. Okay, yeah, atoms. I saw the in a couple days we're doing something, a ball and stick experiment. What is that? Okay. Anyways, so we're learning about. I don't know if I'm like bleeding or what. Sorry. We will be learning about atoms and chemical elements. So real quick, just a good thing to know. Um, they are too small to see without a special microscope, but atoms make up everything around us. So atoms are just the super itty bitty teeny tiny microscopic things that make everything around us based on just a bunch of different sciencey things. Um, sorry, I'm just making sure this isn't honest and naive again. Okay, they're fine. Um, but yeah, so like all matter, so solid, liquid, gases, atoms have mass and volume. So although they are super itty bitty teeny tiny and you can only see them with a microscope, they still weigh something. They're very, very, very light, but they do weigh something. Um, Atoms are extremely small. A water droplet, like the ones hanging from the tip of a leaf in this picture where you see the ladybug, contain more than 1 billion trillion atoms, which is insane, just so you know. All right. Which of the following statements is true? Based on what we just learned, atoms can be seen with the naked eye. Atoms make up everything around us, and atoms do not have mass, so they don't weigh anything. Siwan.
Atoms make everything.
Yes. Yep. Atoms make everything around us. Good. All right. Almost all of an atom's mass is found in its nucleus, so which is its center. So like for us, that's like our tummy. Think of it like that. A lot of my weight is also in my tummy, just so everybody knows. Located in the center of an atom. An atom's nucleus can contain two kinds of particles, a proton and a neutron. The nucleus, so the center of every atom, contains one or more protons, which we'll get, oh, it says right there. Each proton has a positive electrical charge, okay, positive. In many atoms, the nucleus also contains neutrons. A neutron has no electrical charge, nothing at all. So, fun fact, everything has a super itty bitty teeny tiny electrical charge because everything is made with protons and neutrons, which is why, I don't know if you've ever like rubbed your back up against like um like a metal chair and then you like feel electricity go zzz to your fingertips. That's because you're activating all those protons. And then if you've ever like rubbed your socks on like a very fuzzy carpet and then like your hair gets all staticky. But anyways, that's just fun science experiment for everybody to try out. Um, and neutrons, no electrical charge. Determine whether each statement is true or false. All right, so we got three. So in theory, we can have three people participating for this one. First one, a proton does not have an electrical charge. True or false? Reham.
False.
That is correct. The nucleus contains most of an atom's mass. True or false? Sambriti.
True.
That is true. And there is at least one neutron in the nucleus of every atom. That one's tricky, if I'm going to be honest. Oh my gosh. Sorry, so many parents are texting me today. What is happening? Goodness. Siwan. Oh, did you put it in the chat? I didn't even look. True question mark? So yeah, this one is worded weird. So there's at least one neutron in the nucleus of every atom. This one says in many atoms, the nucleus also contains neutrons. It doesn't say in all atoms, it says in many atoms. So if this is saying that there's at least one in all of them, I'm gonna personally say it's false, just because here it says in many, it doesn't say in all. But that's just what I think. So let's find out. Okay, that is right. So again, that one was just worded very tricky. But yeah, so not all neutrons, or sorry, not all atoms have neutrons in them, which is interesting. Okay. Protons and neutrons are found in the nucleus of an atom, all right? Traveling around the nucleus, so they kind of orbit. Think of an atom like Saturn, the planet Saturn. It has a big ring around it, okay? So it's a planet, that's the nucleus, Saturn. the nucleus, and then it has like a ring around it. And then traveling around that ring are the fast-moving particles called electrons. All right? Electrons have a negative charge. An electron is much smaller and lighter than the proton and neutron. So the planet Saturn, right here, this is the atom, and it has protons and neutrons. That's this, okay? That's the center. And then traveling around it, like the ring of Saturn, are all these little tiny electrons, which, in case you didn't know, all Saturn's ring is a bunch of just space rocks traveling it in gravity, in case you didn't know. So it's not just like this big ring you can stand on and walk on. It's actually just a bunch of rocks that are so close together from far away, it looks like there's a ring around it, which is crazy. So based on what we just learned about an electron, what statements are true, and it can be more than one. So first one, an electron has a negative charge. Negative charge. Would love to hear from Chantel or Demetrius, since I haven't heard from you guys yet. Demetrius.
Hold on. Is it?
And you just have to do one at a time. So this first one says an electron has a negative charge.
Is it the second one?
Based on what we read, does an electron have a negative charge?
It's the first one.
The first one is one of the true ones, yes. Come on, click it. It won't let me click it now. Okay, good. Now the next one says a proton is the same size as an electron. If it's true, we're gonna click on it. Does anybody, and Demetrius, you can answer this if you want, does anybody think that this is true? Right? A few people. Okay, interesting. All right, and then this last one says all of an atom's electrons are located outside of the nucleus. Outside of the nucleus. Rehan, is this one true?
Inside of the nucleus, and it says in the text that electrons travel around the nucleus, then yeah.
Yes, that is correct. All electrons are outside the nucleus. They are the rings of Saturn, all right? They stay outside of the planet, okay? And then this one is false because if you look right here, the last sentence says an electron is much smaller and lighter than the protons. So they're super tiny. All right. It uses a Ferris wheel as an example instead of Saturn. So whichever one's easier for you guys to remember. You can think of Saturn as the planet and the ring are the electrons, or you can do that. It looks like a Ferris wheel. You can think of the Ferris wheel, the seats, as the electrons, and then that circle in the middle, keeping the Ferris wheel standing, that's like the protons and neutrons. So whichever one's easier for you to remember, you just think about it. All right. So guys, does it let me play with it? Nope. Okay. No playing. So this is essentially what an atom looks like. We have our neutrons and protons, and then our electrons going around it. Okay. We have our positive, our neutral, and then our negative. So I'm assuming it wants us to label them. Is that what I'm doing? Yeah. So it wants me to label it. So this one is positive. What of these four is the positive one? What of these is the positive one? Does anybody want to tell me? Which one of these am I pulling? Which one of these am I pulling to this positive one? Anis or Ayub?
You're pulling proton to positive.
Yes, guys, protons. Proton starts with a P, positive starts with a P, pro, I'm positive, woohoo, yay, yippee, skippy doo. Think of it like that, just proton, positive, all right, awesome, all right, now I have this gray one, it's completely neutral, no electric charge, it's not positive or negative, it's just in the middle, some breedy, which one's that?
I think it's the uh uh the atom. I don't know.
I think you do know, but it is actually
Oh,
not the atom.
I knew it wasn't.
See, you knew it wasn't, so why'd you say that?
No, because I'm scared.
Don't be scared. You knew that was wrong, so I knew you knew that was wrong,
I don't even know the right one.
which means you know it's either a neutron or an electron.
Uh,
You know.
Electron.
That was a very good guess.
Okay, there's only one choice left.
It's
The
true.
neutron.
Yes. So how I like to remember this one, so this one's gray, it's neutral, neutral, neutron. You can also say no charge neutron. Anything that starts with an
No
N,
charge neutron.
yeah, it's all an N. There's no color, there's no charge, it's neutral, neutron. No, 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 bunch of N's. Just like the positive
Gotcha.
one, yeah, just like the positive one was a plus sign. It's positive. It's proton. So lots of P's. Lots and lots of P's. Okay? So
Gotcha.
now, yeah. So now this one is on the outside. This one's on the outside. All right. It's a minus. All right. This one's a minus, and it's super tiny, and it's like the ring of Saturn. It's like the rings of Saturn. Which one was that? I see one hand. Does anybody else think they know it? Chantel, I still haven't heard from you today. Is this math or science? I'm confused. This is science. I appreciate you typing, Chantel. But right now we're just kind of learning vocabulary. We're starting a new chapter today in science, and it's going to be about atoms. So, and atoms are just the super tiny itty bitty things that make up everything in the entire world. So, yeah. But that's what we're starting. All right. Oh, I didn't even read the top part, guys. Whoops. An atom is an example of a system or a group of objects that interact with each other. Scientists often use a model to represent a system that is hard to see. Models can also be used to show a complicated system in a simpler way. Because atoms are so hard to see, people use atomic models to represent the way protons, neutrons, electrons are arranged in an atom. The diagram below shows an atomic model. Boom. Well, there you go. Look at that. So, Reham, since yours is the only hand I see, what is this one on the outside? What's this minus?
Electrons.
That is correct. That is correct. Guys, you can think electron, the electricity is on the outside. The electricity is on the outside, all right? It's gonna zap you. It's gonna make you feel negative. It's gonna make you feel sad and minus because you don't wanna get zapped because that always shocks people and they're like, ah, you know, they freak out a little. Electron, the electricity is on the outside. All right. Now, this entire thing here is called a what? I should see everyone's hand only because there's only one option left. All right. Should see a lot of people's hand. Chantel, I'm calling on you for this one. Did you type it? I don't want to get shocked. Same. Chantel, what's the answer?
Electron.
The entire thing? So the entire thing is not an electron. We only got one option left. What blue word do we have left at the top?
Proton.
Sorry, so that's at the top of this side. What's our last blue word up here though? In our word bank.
Atom. I don't know if I had to say that word.
Yeah, no, that's a weird word, but yes, it's an atom. So this entire thing is called an atom. Inside the atom are these three things, the proton, electron, and neutron, but the whole thing together is called an atom. So, boom, there we go. All right.
Is that how a battery works?
Yeah, battery. So a battery works off of atoms. A battery uses substances that give off more protons, and then where the other side gives off more electrons, and then once they combine their positive and negative charge, they create a constant electric flow because the negative electrons are going to the negative ones out onto the other side, and they're bouncing off of each other constantly because if you put two electrical charges on the outside together, you can't keep electrons. So like in an atom, if I have my electrons and I have my electrons, you can't lose or gain them really. So then the electricity is like, oh, I want to go here. Oh wait, I can't. Okay, I want to go here. I want to go here, but I can't. And then it goes by so fast and it just never stops, and that's what causes electricity, and that's how it gives power to like remotes and things like that. But eventually the electricity does die because the battery runs out of it eventually gets tired. The electrons are like, I'm over this. I'm so done. I don't even want to do this anymore. And then they just die. But yeah. It's definitely super fun. Playing with batteries was a very fun science experiment to do back in school. All right, well, here we go. So below we have two atomic models, each represent a different atom, right? This one has 3 proton, 3 neutron, and then we got electrons going on the outside. This one has 3 protons, 4 neutrons, and then 2 electrons on the outside. So they are completely different. The 2 atoms represented above contain the same number of what? They have one thing in common. Everything else is different. What do these 2 atoms have in common? Honest.
Proton.
Yes. Well, let me click it. Come on, let me click. Boom. Yes, protons. If you looked closely, there's 3 plus signs. There's 3 protons here, 3 protons here. Everything else is different. So good job. All right, next one. Oh, it wants to teach us something. Did you notice that the 3 electrons in the model of lithium, so I guess that's lithium, appear on 2 different circles around the nucleus? So there's one on this ring, or there's 2 on that ring, and then 1 on the outside ring. These circles are called electron shells, and they represent how electrons are organized in an atom. Each shell can hold up to a certain amount. For example, the shell closest to the nucleus, right here, can hold only 2. When an atom has 3 electrons, the 3rd electron occupies a different shell. Boom. And we'll get into that later. We'll talk about like why that is the way it is. So don't worry about that right now. The number of protons in an atom is known as its atomic number. Atoms that share the same atomic number are classified as the same chemical element. All right. So a lot of liquids have the same atomic number, because if like water has, I don't know, 2 protons, but then what's another liquid that's like not poisonous? Juice. We'll just say juice. So juice, which is water-based, also probably has 2 protons. They're the same chemical element because they're both liquid. The only difference is that juice has a little bit of extra stuff, whereas water doesn't. And then we'll talk about that obviously a little bit later. But yeah, anything that has the same atomic number, the same number of protons, they're the same chemical element. So like gases are all the same element. Liquids are all the same element. Solids are all the same element. So a lot of them all have the same protons. The thing that differ though are their neutrons and electrons. Okay. Below is a model representing an atom of the chemical element lithium, which, Chantel, that is what is in a battery, lithium batteries. If you ever go to the store and you buy batteries and you see the word lithium, you can be like, oh my gosh, Mr. Hughes taught me about that. That lithium batteries are its own atom and have its own this and own that, and just super fun. So what is lithium's atomic number? Remember, it's based off of how many of one of these there is, but which one? Which one, and then what would my answer be? Chantel, is your hand up to answer? Because if so, I'm calling on you. That was a no. You just put it down. Okay. Again, it wants to know its atomic number, meaning based on how many protons, neutrons, or electrons, we can tell what its number is. We can tell if this is a solid, liquid, or a gas, basically. Sambriti.
5 or 7. I don't know.
I see what you're doing. So you're counting everything. You don't want to count everything. It's only one of them. Only one of them. Proton, the neutron, or the electron. So the answer has to be 2, 3, or 3. But which one? Because it's only one of those groups.
3.
3, okay, you're right. Are you doing 3 because you see 3 protons, 3 of the yellow pluses? Or are you doing 3 because of the 3 gray dots, the neutrons?
The protons.
Good. Yes. Yes. All right. It is 3 because of the protons, not the neutrons. Good job. Now, which of the following models also represents a lithium atom? Okay. So, which one of these also represents a lithium atom? Keeping in mind, all lithium atoms have one thing very specifically in common. Ayub.
The first one.
Ayub, why did you pick that one?
It has 3 protons.
Yes. So guys, this one also has 3 plus signs. This one also has 3 plus signs, so it has 3 protons. So that means we know that they're the same. They're both lithium. This one might have more neutrons and some more electrons, but that just means that that battery is stronger, okay? But at the end of the day, it has 3 protons, so it is still lithium, all right? Pretty good, okay? Oh, wow, that's a lot. Whew. Yeah, we're gonna be getting into these, so those 2 bold words, isotopes and then ions, all right? We will get into those. I don't want to overwhelm you guys today because I want us to focus on proton, neutron, electron, and atom. So we'll talk about other vocab words later. Also with this, we will talk about more of those later, because I would much rather us remember the few things instead of being overloaded with too much information and then not remember anything. You know what I mean? I'd rather you guys remember 4 words instead of no words because we talked about too many. So guys, I don't know if you've ever seen the periodic table. I'm gonna pull it up for you real quick though. The periodic table. If you have, that's awesome. If you have not, I'm gonna show you and then you'll be like, oh, I've definitely seen something like that before. So guys, if you've ever seen it, that's great. This is the periodic table. Okay, if you've ever seen it, you might have seen it in like a science show. If you watch crime shows or like murder mysteries or anything, you'll see this sometimes in like the scientist lab when they're testing like, you know, the bullet or they're testing DNA or something. So guys, this is the periodic table. On here, these are all the elements that we have in the entire world. Out of the entire world, these are all the solids, liquids, and gases that the entire world has ever found. All right, so all of them. So there's not a single thing in the world that that we have not found or been able to identify that doesn't work with this list. So this list is everything. As you can see, you see a little number at the top. That's its atomic number would be on the bottom. There's numbers at the top to organize this whole thing. And then there you see 2 letters. The 2 letters are just kind of like, I don't know. I guess you can think of it like initials. Some of them, it works for initials. Some of them, it's just their 2 letters. Like AU, is it AU or AG? Mr. Hughes doesn't know. One of those is silver. And you would think it'd be like SI for silver or SL. Turns out it's AU or AG. I don't remember which one. It's one of those though. Helium, if you've ever, put helium inside of a balloon and sucked the helium out and made your voice really high, that's the one all the way up here, the 2. It says HE, helium. Oxygen, which we all breathe, that's number 8. That's just a big old O, because oxygen, there's a lot of oxygen obviously in the world. And neon, if you've ever seen a neon light, or like you've gone somewhere with like an open sign and it's like, we're open, and it's like flashing, that's over here. That's number 10. That's Ne. That's neon. It's actually a special gas that they put inside of a glass tube, believe it or not. So if you ever broke an open sign, which I do not recommend, you would definitely want to be wearing a gas mask. If you ever broke it, all the neon gas would leave that glass tube. And then if you plugged it back in, you wouldn't see anything because the light, you'd see like a light bulb, a little tiny one, but light makes neon turn different colors. It's really interesting, actually. But yeah, this is the periodic table. This is all solids, liquids, and gases. Super neat. So we're gonna go through that, I think later. But an atomic symbol for a chemical element is the short version of its name. The atomic symbol consists of 1 or 2 letters. The first is always a capital letter. AG is argentium, which must mean AU is silver then. But for argentium, oh no, it literally says argentium, which means silver. Interesting, so AG is silver. I knew it was one of them. The Latin word for silver is argentium, which is why they picked AG and not SI. So us Americans call it silver, but I guess over in, I was about to say over in Latin. Mr. Hughes needs help. Overseas in Europe where they speak Latin, they probably say argentium in some way, shape, or form. That's hilarious. So, based on what we just learned, the atomic symbol blank represents the chemical element blank. All right, again, the atomic symbol are the special letters that represent a thing, and then the chemical element's usually the name. So what can we do with these ones? What can we do with these three choices to put in these two boxes? Has everyone participated at least once? I think everyone has participated at least once except Deshaun. Good. Ayub.
You can put Ne as the atomic symbol, and it represents neon.
Yes. Yes, as we just talked about, the symbol is Ne. That's just to shorten it because honestly, I mean, neon, we're lucky. Neon's a pretty short word, but there's a lot of other ones that are very long, like hydrogen peroxide or monoxide ionized, or glycerol. There's just a bunch of really long ones. So we shorten it with the symbol, which is just those two letters, Ne for neon, and it represents the element, and then that would be its name. So good job. Boom. All right, here's the periodic table that I briefly got to show you. Oh, it lets us zoom in. Nice. So that is this. I don't know why we're supposed to zoom in. I guess we're supposed to look at one of these. But if we zoom in, guys, you can see some of their names are just things like you're like, I didn't even know that existed. We know gold, we know platinum, we know well, some of you might know mercury, silver, but there's other things on here. Ooh, rhenium, fun fact, cadmium, that's actually used in paint. Just a fun fact. But yeah, some of these things like we probably have never heard of. Mr. Hughes hasn't even heard of some of these. Like hassium, I don't know what that is, but I'm glad scientists do. Because some of these could be used in medicine. Some of these, could just be random rocks. You never know. It's very interesting if you're into this kind of stuff, you know what I mean? So based on all of this, the element hydrogen is highlighted in the periodic table above. The one with an H, each hydrogen atom has one proton in their nucleus, so its atomic number is 1. So all the way up here, will let me go? Yes. So as you can see, H is first, hydrogen, and it has a 1. That's because it has 1 proton. Okay, we just learned earlier 3 protons is lithium. That's what we use in our batteries. All right, anything else with more, are all these other ones. So which one's like the most? This one, OG. That's funny. OG, whatever that is. Organism, that one has the most. Those are a lot. That's a lot of protons. So yeah, so the periodic table is organized by atomic number. Notice that the atomic number increased from left to right. Use the table to complete the sentence. The chemical element with the atomic number 14 is blank. Its atomic symbol is blank. So let's go find 14. Okay. Go up. Oh, will it not let me go up? Sadness. I want to do up on this thing. It's not letting me. Aha. Okay, so guys, we found 14. So it wants us to know which element is the atomic number of 14 and then what's its symbol. So can someone tell me? Rhenium.
14 is silicon, and its symbol is Si.
That is correct. Yes. So guys, silicone, it's kind of just like a really tiny plasticky kind of thing. I'm trying to think because Uh, there are certain products, if you've ever opened and you've gotten just like this little bag of like, it almost feels like beads, this little itty bitty tiny bag of beads, you'll see on it, it says this bag contains silicone. Be very careful.
Called
Blah, blah.
silica.
You said what?
Called silica. Like the tiny beads you find in shoes with the bags.
Shoes, that's what it is. Yes, it's in shoes. But that's this. That's the element, silicon. Silica, silicon, same thing. One's just a different accent from a different language. We call it America would call it silicone. Others say silicon, some say silica, but it's all the same thing. But yeah, like Reham said, you'll find it in like shoes. You'll see that just little itty bitty bag of beads of silicon. That's because leather, which is what most shoes are made out of in some way, shape, or form, and rubber, silicon is a solid that emits just like this gas, which sounds super weird. And it keeps things nice and soft in the size, and it doesn't let humidity or anything affect it. It's like an insulator. It's really cool. So Reham said silicone and SI. She is correct. So it's this one right there. Submit. Boom. Whoa. We're not reading that because Mr. Hughes didn't want to read that. Hey, lots of stuff. Back in the day, a ruler believed it. Yes. Live long, mercury contains food and dead. Yes. Yeah, back in the day, rulers did have mercury in them. Actually, if you use an old-time thermometer and you've ever seen it in a video or something, and you see that little red line going up, and then like at the top is like a little red circle. You see it in cartoons too, where the thermometer is just like bam, bam, bam. That is mercury. Mercury reacts with heat, and based on that, it moves the red dye up. But if you broke one of those glass thermometers, you'd see mercury, and touching it is poisonous to your skin. It's poisonous to your lungs. You can't touch it. You can't drink it. You can look at it, but that's about it. Because if it gets on you or in you, it is very, very poisonous. You have to immediately go to the hospital. It's ridiculous. It's crazy, for sure. But yeah, all right, guys, so we're going to use this table to finish all of this stuff. So helium, atomic number 2. All right, I see it. It's up there. Okay, so I don't like, okay, helium, boom. So what's its atomic symbol? I would love to see more than just the same 3 people. And Deshaun, I haven't heard from you at all yet. Nobody other than the same peeps. Somebreedy, what's its symbol?
HE.
Yes, for helium. Now, guys, there's another one. Its symbol is SN, and its number is 50, so let's go find it. And then it wants us to know what its name is, okay? So I see it right here, SN. Let's zoom in a little. So I see it. So what's its name? Again, I should see everyone's hand up because that is the easiest name. It is 3 letters. Everyone should know this one. So I personally think it's ridiculous that only 3 people want to participate, seeing as how the answer is the easiest word to say. But okay, honest. Specifically, it has to be honest, not Ayub.
10.
Yes, it is tin. All right, tin foil. You guys know what tin foil is? You use that when you cook and you wrap stuff up to keep it fresh, and you put it in the fridge. Tin foil. We use that. Just, you can use that every day if you really want to. Okay, there's this one. Atomic number is 20. We don't know anything else about it though, so let's go find it. Okay, can I scoot over? Oh, so it's going to be on the other side. It's going to be all the way over here. I don't want to go that way. Oh, it won't let me. Aha. Okay, so we only know 20. We need to type its atomic symbol and its name. What is it? Did Chantel leave? She did. Ayub.
Calcium.
Calcium. And like Ayub said, that is in your food. And it's a vitamin, which is very good for you. And it is good for bone, not structure, it's good for bone strength, which is why people tell you to drink your milk, because then it has calcium and keeps your teeth strong, it keeps your bones strong, you know, stuff like that. So super fun. Submit. And helium is the second most abundant element in the universe, following hydrogen. 23% of all ordinary matter is helium. Whoa, I did not know that. Many stars, including the sun, create helium through a process called nuclear fusion. The sun uses nuclear fusion to turn 600 million tons of hydrogen into helium every second. Nuclear fusion occurs in the center of the sun and releases an incredible amount of energy. Some of this energy escapes through the sun's surface. The photograph shows energy escaping as ultraviolet light. That's cool. That's really cool. That's interesting. So, well, we wouldn't live if we got close to the sun, but based on this, I'm assuming if you breathed in all that helium, your voice would be really high. You'd be dead, but you'd be dead with a very high voice. All right, how many more do we have? This is fun. Oh, this is the last one. Whoa. And it wants us to fill in the blanks. Yikes. Milk makes me feel sick, tastes good, but makes me feel like I have a question. Oh. That's fair. Okay, guys, we're filling it in, okay? Which just looks like definitions, okay? So, this one, all atoms contain one or more positively charged particles called what? What is our positive particle that we learned about? Reham.
Protons.
Yes. Boom. All right. Which are found in the atom's nucleus. In many atoms, the nucleus also contains blank, which has no electrical charge. Nothing. It's no electrical charge. No electrical charge. No, 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 no. Honest.
Neutron.
A neutron, yes, because it has nothing. It's neutral. The number of protons in an atom is the atom's blank. The number of protons is the atom's blank. Somebody.
The third one.
Yes, the atomic number. Keyword, number. Number of protons, atomic number. Number. Okay. When two atoms have the same atomic number, they are classified as the same blank. The example that it gave us earlier was lithium, which is a battery. So if they have the same amount, or if they have the same atomic number, they're classified as the same what, Reham? Did she type it? She typed it.
That it.
Would element, yes. They're the same element. They're both batteries. They're both the same thing. All right. And Ayub.
Atomic symbol.
Yes. Yeah, the last one, it literally says, including a short version of the element's name, atomic symbol. Because again, when eventually, I think you talk about it more in like 8th grade, but like when you're doing thing like nitroglycerol added to hypoxy carbohydrate or whatever, like you don't want to write all that out. You just want to use their symbols. Boom, we're done. Yay, science. So stop share.